right, hello everyone. My name is Michael, and we're going to be looking at problem number 5 from our target round of test 12502, which was our high school test release from November 2024. So let's go ahead and take a look. Let A be the sum from I equals 0 to 673 of x to the power of 3i, and let B equal x cubed minus 1 quantity squared plus the summation from j equals 0 to 672 of x to the 3j plus 1 times the quantity x to the fourth minus x squared for some real number x such that the absolute value of x is greater than 1. Given that a times b is 1/100th, x to the 2022nd power can be written in the form p over q for relatively prime positive integers p and q, and we want to compute p plus q. Now note that a, right, if we expand a here, right, we have this messy summation. So let's see if we can do something nicer with this, right? A, x to the 3 times 0 is 1, and then x to the 3 times 1 is x cubed. And then if we keep evaluating out terms, right, we can see that this is just a finite geometric sequence with first term 1, right? First term of a geometric sequence 1, common ratio x cubed, and the number of terms is 674 because we are summing from 0 to 673. So that's 674 positive integers. Now, the formula for the value of a finite geometric series, or in other words, the sum of these terms in a finite geometric sequence, is a times the quantity 1 minus r to the n over 1 minus r. So using that, we can see that a is equal to the first term 1, right? A is our first term. We have that r is the common ratio, right? What each term is multiplied by to get to the next, and then n is our number of terms. So that gives that a is equal to 1 times 1 minus x cubed quantity to the 674th power over 1 minus x cubed. So this is equal to x to the 2022 minus 1 all over x cubed minus 1. Now let's see what we can do with b. Right, what can we do with b? Now, b is a bit more complicated, but we can leave this x cubed plus minus 1 quantity squared on the outside. Now, what is happening after that? Well, the first thing we can notice is that x to the fourth minus x squared, quantity squared, is equal to x times the quantity x cubed minus 1 all squared. So what we can do is pull out an x squared from that. So we can turn this summation into summation from j equals 0 to 672 of x to the 3j plus 1 times x squared times x cubed minus 1 quantity squared. Well, x to the 3j minus 1 times x squared is x to the 3j plus 3, which is x to the 3 times the quantity j plus 1. Now, if we evaluate the first couple of terms of b, that's going to give us b is equal to x cubed minus 1 quantity squared. And then starting from j equals 0, that's going to be x cubed, right, times x cubed minus 1 quantity squared, plus x to the 6th times x cubed minus 1 quantity squared, and so on and so forth until that final term is going to be x to the 2019 times x to the cube minus 1 quantity squared. So for b, our first term is going to be x cubed minus 1 quantity squared. Our common ratio is going to be x cubed, and our number of terms is also going to be 674 because we only have 673 here, but there's one more out here. So that means that the value of b, right, is going to be x cubed minus 1 squared times that's going to be 1 minus x cubed to the 674th over 1 minus x cubed. So that's going to equal x to the 2022nd minus 1 times x cubed minus 1. Yeah, all right, cool. So now that we have that, right, we know that a times b equals 1 over 100. So that means that x to the 2022 minus 1 over x cubed minus 1 times x to the 2022 minus 1 times x cubed minus 1 is equal to 1 over 100. These cancel out, right? X cubed minus 1 cancels out, so that means that x to the 2022 minus 1 quantity squared is equal to 100. So therefore, x to the 2022 minus 1 is equal to plus or minus 1/10. But we know, right, that since the absolute value of x is greater than 1, that gives us that x to the 2022 power is equal to 11 over 10. Now, 11 over 10 is already expressed as a common fraction as the ratio of two relatively prime positive integers. So that means that p equals 11, q equals 10, and p plus q is equal to 21. And that is our answer to this problem. So really important for this one is knowing how to work with summations, how to expand them, but also geometric sequences and series. So always important to know those.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.